You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Cloud Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. High availability, or HA, is the practice of designing systems to minimize downtime and ensure continued access to services even when failures occur. In cloud architecture, this principle is implemented through geographic distribution, system redundancy, and automated recovery mechanisms. The goal is to ensure that services remain operational across planned maintenance, infrastructure outages, or unexpected incidents. The Cloud Plus exam includes HA concepts in planning, deployment, and disaster recovery domains. Availability zones are isolated segments within a cloud region. These zones operate independently, with separate power, cooling, and network connectivity. Deploying resources across multiple zones ensures that a localized issue, such as a failed router or a fire suppression event, does not bring down the entire service. Cloud Plus candidates are expected to understand how zone separation supports HA and how to architect across zones to improve fault tolerance. A cloud region is a defined geographic area that contains one or more availability zones. Deploying services across regions adds an additional layer of protection by reducing the impact of localized disasters, such as natural events or national-level network disruptions. Regions also help with data sovereignty and latency optimization. The Cloud Plus exam may present a scenario where resources are confined to one region and ask how to redesign for better geographic redundancy. Zonal redundancy is the practice of deploying resources across multiple zones within a single region. This protects against failures that affect one zone but not the others. Regional redundancy goes further by distributing workloads across separate geographic regions. This helps in cases where an entire region becomes inaccessible. Cloud Plus questions may compare the two types of redundancy and ask which one best addresses a particular failure scenario. System-level redundancy includes deploying duplicate components for compute, storage, networking, and security. These redundant components may operate in active-active or active-passive configurations. In active-active, all nodes handle traffic simultaneously. In active-passive, a secondary node stands by and activates only when the primary fails. Candidates should understand the design and cost differences between these models when planning for HA. Load balancers are essential tools for maintaining availability. They distribute incoming traffic evenly across healthy nodes and redirect requests away from failed nodes. Load balancers can operate at different layers, including Layer 4 for transport-level load and Layer 7 for application-aware routing. The Cloud Plus exam may present a scenario involving node failure and ask how a load balancer should respond to maintain service continuity. Data redundancy ensures that important information is available, even if a primary system fails. This is achieved through replication, where data is copied from one location to another. Replication can be synchronous, where updates happen in real time, or asynchronous, where data is copied on a delay. Synchronous replication ensures consistency, but adds latency. Asynchronous replication improves performance, but risks data loss. The exam may ask which type of replication suits a workload with specific recovery point requirements. Storage redundancy includes technologies such as RAID, object replication, and snapshot-based backups. Each approach offers different benefits. RAID provides fast recovery from disk failure. Object replication distributes storage across systems or zones. Snapshots allow point-in-time recovery for fast rollback. Cloud Plus candidates may be asked to choose the right storage protection method based on failure scenarios or RPO targets. Fault isolation refers to the ability to contain and localize failures. In cloud environments, isolation is implemented using fault domains, which group components that may fail together. Designing for fault isolation ensures that a problem in one area does not cascade into other systems. For example, Placing all instances of an application in one fault domain may lead to a complete service outage. Cloud Plus may test knowledge of fault containment strategies to prevent single points of failure. Availability metrics help quantify how often a system remains online and usable. These metrics are usually defined in terms of nines. For example, 99.9% uptime equals roughly 8 hours of downtime per year. 99.999% uptime reduces that to a few minutes. Each increase in availability requires greater investment in redundancy and complexity. The Cloud Plus exam may ask which design approach supports a given SLA availability target. Uptime metrics influence architecture decisions. For services that cannot tolerate any downtime, regional redundancy and continuous failover systems may be required. For systems that can handle brief outages, zonal redundancy may be sufficient. These decisions affect not only cost, but also performance and operational overhead. Candidates must align design strategies with stated availability goals and recognize when a given solution meets or falls short of a required target. Redundant systems must also consider the failure domain of shared services. A load balancer, for example, becomes a single point of failure if not configured redundantly. The same applies to DNS resolution, firewalls, or database engines. Candidates must understand how to duplicate supporting infrastructure, not just application components. Cloud Plus scenarios may involve incomplete redundancy and ask which component introduces the risk. Designing for availability is not just about adding more instances. It is about distributing resources in a way that isolates failures, minimizes risk, and supports automated recovery. Cloud Plus requires fluency in identifying availability risks, understanding redundancy options, and designing systems that reflect stated uptime and recovery goals. High availability has a direct impact on cost. Adding redundancy across zones, regions, or components increases infrastructure usage, licensing consumption, and operational complexity. Businesses must weigh the cost of downtime against the expense of preventing it. For some internal systems, a short outage is tolerable and cost-saving measures are appropriate. For customer-facing applications, every minute of downtime may result in lost revenue. Cloud Plus may present scenarios where budget limits exist and ask which design change preserves HA with the least expense. Health checks are essential for maintaining availability. These automated processes test whether systems are responsive and performing correctly. If a health check fails, traffic is rerouted or a failover sequence begins. Health checks can operate at different layers, such as pinging an IP address, testing a port, or validating application response. The Cloud Plus exam may describe a failed node and ask how HA responds or what failed to trigger the failover. DNS and global traffic managers contribute to availability across regions. These tools route users to the nearest or healthiest endpoint, improving both performance and fault tolerance. In the event of a regional failure, DNS records can be updated or automatically redirected to an alternate region. Cloud Plus scenarios may describe a user unable to connect and ask whether a DNS or traffic manager failure is responsible for the disruption. Network redundancy protects against total path failure. This includes deploying redundant routers, switches, gateways, and virtual network appliances. Redundant paths ensure that if one route fails, another is available. Load balancing can also be applied to network traffic to prevent saturation on any single path. Cloud Plus may describe a networking issue and require the candidate to identify where redundancy was missing or improperly configured. Configuration drift can compromise high availability. When redundant systems are not configured identically, a failover may not work as expected. For example, if only one load balancer has an updated rule set, traffic may fail when rerouted. Regular testing and configuration validation are required to maintain consistency. The Cloud Plus exam may ask what caused an HA failure during an otherwise successful failover attempt. Monitoring tools must support availability awareness. This includes tracking uptime, latency, error rate, and node status. Alerts from monitoring tools must be routed to support channels that understand HA context. For example, An alert about a single node failing in a multi-node cluster may not need urgent escalation unless other nodes are also failing. Cloud Plus may test alert prioritization and ask which metrics best support availability goals. Redundant configurations must be validated through periodic failover testing. Without real-world exercises, teams may not discover configuration issues, permission errors, or timing mismatches. Failover testing includes simulating a component failure and observing whether traffic, processes, and data access continue uninterrupted. Cloud Plus may describe a failed test and ask what step was missed in HA planning or testing. Availability requirements must be built into deployment templates. Infrastructure as Code, or IAC, tools should define multi-zone deployment, health checks, failover logic, and monitoring integrations. This ensures that new deployments maintain the same HA characteristics as the original design. The Cloud Plus exam may reference a template that lacks HA settings and ask what feature is missing or should be added. SLA alignment determines how much redundancy is required. An SLA of 99.9% uptime requires only minimal zonal redundancy. An SLA of 99.999% may require global failover and continuous replication. Each level of availability requires a proportional investment in architecture, tooling, and testing. Cloud Plus may describe an SLA and ask what level of redundancy is needed to support it. Cloud-native services often include built-in availability features. These include managed database clusters with automatic failover, replicated storage services, and zone-aware networking. Leveraging these features reduces the need to build custom availability layers. However, candidates must still understand how these services work and whether they meet the specific requirements of the business. The Cloud Plus exam may ask how to choose between building redundancy and using a provider's built-in option. Operational documentation must include availability procedures. This covers how failover is triggered, how alerts are handled, how systems are restored, and what time thresholds are acceptable. Without this documentation, support teams may respond inconsistently or miss critical events. Cloud Plus may present a failure response timeline and ask which step was missing or delayed due to unclear documentation. Achieving high availability is not a single configuration or purchase. It is a strategy that affects every part of cloud architecture. Each layer, from compute to storage to network, must include redundancy, monitoring, and validation. Cloud Plus candidates must apply HA principles in both proactive design and reactive troubleshooting, ensuring systems remain available even under stress or failure conditions. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.